Hello, it's David from David Savory Electrical Services, and today I'm out in the rare sunshine in all its glory to make a quick video about a relatively new item to market, the Quickwire switch and load. Now, I've had this for a few weeks. This one here happens to be a free sample from Quickwire themselves, and I haven't used it out on site yet as I've been waiting to make this video. But making videos takes a long time to do, and there aren't enough hours in the day, or at least not enough sober ones, so it's taken a while to get around to it. But enough of my excuses. Let's have a look at what problem this gadget solves, and indeed it is a problem, one that I've blogged about before on my website. It's the age-old issue of trying to shoehorn new light fittings into dwellings that use the three-plate wiring method. Let me explain. Most UK homes have electrical wiring which dates back to the 1960s or later. Hopefully houses older than that have since been rewired, but from the 60s until relatively recently, houses were built with their lighting circuits arranged in a method called three-plate or loop-in. A plastic ceiling rose, such as we have here, has a feed cable from the fuse box or consume unit, a feed cable out to the next light in the chain, and a third cable which goes to the light switch and back. The next light in the chain will look the same, with its own feed in, feed out and switch cable. And this daisy-chained wiring arrangement goes on and on all the way to the last light in the chain, where there is a feed in and switch but no feed out. This wiring method is known as three-plate because in the ceiling rose there are three separate electrical terminals. The feed in and feed out neutrals go to this terminal, which also connects to the local lamp holder. The line in and line out connect to this central terminal, which also connects to the switch line out, and the switch line return connects to the third terminal, which goes to the local lamp holder's line wire. This is a fairly efficient method of connection as far as the wiring is concerned. If we were to run the feed cable through the switch position and to the light instead of having it junctioned at the rose, then it would require the neutral to be junctioned at the switch point and be wasteful in wiring, as there would be no advantage of having the neutral routing through the switch, at least not unless you wanted the ability to spur a new light point from the switch position or to have a self-contained load such as an illuminated switch. You would also still need to have a junction at the switch or somewhere to take the feed out to the next light. So the idea behind the three-plate method, as well as saving on copper wire, was that people would know where the junction point is, and it wouldn't change their people wouldn't change their ceiling roses anyway, as if a splash of colour or style was needed in any given room, then they'd just change the lampshade hanging off the plastic pendant. However, styles change, and these days people don't necessarily want white plastic pendants and instead prefer shiny bling lighting that offers a greater aesthetic than just a change of lampshade. So they potter off to the likes of John Lewis, Argos, Homebase, B&Q and end up buying a flash new light fitting like this one. Now, while this light fitting looks nice in a retro kind of way, it's a headache for the installer because, as you can see, it has a single three-way connector block designed to only accept one cable, not the three cables that actually hang out of most ceilings. I get a lot of jobs where people buy new lights, scurry up the ladder at the weekend thinking it'll be a case of one off, one on, and then find themselves surprised by the number of wires they are actually faced with. To add to their confusion, the switch cable is often a two-colour cable, as in this case here, where brown and blue has been used. So this blue looks like it's a neutral when in fact it's a switched line. That's why my blue cable here has some brown sleeving on it, to indicate it's actually a line wire and not a neutral. But house builders of old didn't bother with sleeving, so in many cases the switch line is indistinguishable from the neutrals once they've all been disconnected. Getting wires in the wrong place upon reconnection can result in things going bang or not working at all. Just to add to the confusion, my cables here use brown and blue, which are post-2005 colours, but pre-2005 the colours would have been red and black. There may be instances where old meets new on an installation, with you having to decipher the functions of brown, blue, red and black wires if no colour-coded sleeving has been used. So you've bought your new light fitting, and to your dismay you find many more wires coming out of your ceiling than you were expecting. The instructions that come with your new light only mention connecting line, neutral and earth, but there are two neutrals, three earths, one switch line and three permanent lines all in your ceiling rows. So how do they fit together in this lamp? Well, they don't, not as it is. Even worse is when you have a class 1 metal light fitting pretending to be a class 2 double insulated light because it comes with one of these shitty plastic enclosed connector blocks that only one cable can physically fit into. The only way for such a luminaire to maintain its double insulated class 2 rating when butchered onto three-plate wiring is if that wiring is completely over-sleeved and the connectors are enclosed so that there is no single layer of insulation anywhere near the metal parts. That can be tricky to do, especially if there is little room to play with in the rose portion of the new fitting. And bad installers or DIYers don't bother, as I know from my electrical inspection work. Another option when faced with the 3 cables out of the ceiling to 1 cable entry at the light is to junction the cables externally so that only 1 cable comes from the ceiling and enters the light. Now there are various solutions we can employ for this, such as small screw junctions and these plug-in socket arrangements, and external connector housings, enclosures. These junction examples will allow us to contain and enclose our cables so that no basic insulation remains exposed, but they're all quite large, and putting a hole into the ceiling to physically push these into is going to leave some damage that this kind of ceiling rose isn't going to cover over. Besides, a plasterboard ceiling is a fire barrier, so putting holes into it will reduce the effectiveness of its fire stopping qualities. And indeed, when I'm performing an electrical inspection, one of the tick boxes on my form specifically asks about the size of holes in the ceiling above ceiling lights. Not downlights, which have their own set of tick boxes to satisfy, but the holes behind pendant fittings. Many sparkers get around this whole headache by performing the junctioning with a chop block and wrapping it in electrical tape, but that is not a compliant or professional method of enclosing single insulation wires or live metal parts. So what's to be done? Well, enter the Quickwire switch and load. The Quickwire switch and load is a 4-terminal junction box which is internally wired in the 3-plate method. You take your 3 cables coming out the ceiling, strip them as I have done here, and then you simply insert them into the Quickwire device. So your loop in goes the right way around into the terminal marked power, and your loop out goes into the second terminal marked power. You can see just clip in, no earth sleeving required. And the switch line, the switch point goes into the terminal marked switch, doesn't matter which way around that goes of course. And then finally you take a new piece of wire and push that into the load side. Again, observing polarity. There we go. Excuse me. The internal wiring of the Quickwire ensures they are all connected together accordingly inside the thing. So you're left with a single cable that your new light was designed for, while the slimline nature of the Quickwire enclosure allows you to shove it through a relatively small hole in the ceiling, certainly a much smaller hole than any of the other alternative enclosures we saw earlier. The Quickwire complies with the requirements for BS 5733MF. I don't know how well the camera can pick that up in the sunshine, but the maintenance-free logo is actually on the thing there. That means it can be installed in locations where it cannot be easily accessed again afterwards, unlike some of the other types of connecting arrangements which use screw terminals. Now, in a previous video I had comments from international electricians stating that electrical junctions must always remain accessible, which obviously by design, if you can, then that's great, but here in the UK regulation 526.3 allows the use of maintenance-free junction connectors so long as the equipment is designed for such and sports the MF logo, as this does here. It must also be installed in the manufacturer's instructions, derated accordingly, and connections can only be retrieved with the use of a tool. And indeed, these things are clamped in here. The only way I'm going to get the cable out is with this little tool here, which hopefully, if I do it right, there we go, will release the device and allow me to extract the wire. Now, as far as regulation 526.3 and BS 5733MF are concerned, this clamped connection is as good as a solder joint, crimp or other such permanent connection, so access isn't required for maintenance, unlike with a screw terminal junction. I mentioned derating a moment ago, and you can see that this doohickey is rated at 16 amps. Well, I say you can see it, I don't know how well you can see it with the sun there. But 16 amps is above the normal 5 to 10 amp rating of the usual lighting circuit. Regulation 559.5.1.204 limits lighting circuits using common lamp holders such as the bayonet cap B22 or the Edison screw E14 and E27 lamp holders to a maximum of 16 amps anyway. So the Quickwire should be fit for any lighting circuit using this style of luminaire and should be naturally derated for most applications, as the protective device is going to be a 6 amp breaker in the majority of domestic installations at least. If you want to secure the Quickwire, say to a joist or something, then a bracket can also be sourced to clip around it there. Now this is all very well if the wires protruding from the ceiling are a standard 1 to 1.5mm twin and earth and have enough length on them to fit properly into the thing, especially as a switch wire needs to mate with the underside of it. Around where I live here, the greenfields are being covered over with new housing developments in which the builders fit the white plastic ceiling roses throughout, then people move in and ask the likes of me to put up their new lights. In these sort of installations where the wiring is new and you have a better chance of some slack being on there, then this is probably going to be a bit of a winner. In older installations where the wiring may be a bit ropey and has been chopped and mangled over the years, then it might not work so well. It really does depend on how much you can safely pull through the ceiling to make a good connection ends that can properly mate with the doo-wang. I should say that modern house builders are aware of this whole headache with the 3-plate method, and on some sites I've been to they are wiring houses now in 2-plate, so neutral passes through the switch and only one wire is present at the luminaire, allowing for easier changeovers of light fittings. One of the Quickwire product to plug is the Quickwire splitter, which looks nearly identical to the switch and load but is wired differently internally. The splitter is designed for where a single light fitting is to be changed into multiple or downlight arrangements. You push the cable that serve the old single light fitting into one of these terminals, and you then have up to 3 output cables that can go off to other lights or to other splitters. City Electrical Factors are one stockist of these products, although I had to push my account manager to confirm pricing and availability. I've been quoted VAT excluded prices of £4.16 for the switch and load or for the splitter, and £7.21 for a packet of 20 clips or a packet of 20 removal tools. Why they're supplied in packs of 20 I don't know, as I don't know how many times a removal tool can be used before it might break, but I imagine so long as you have a couple to hand you shouldn't be in much trouble, especially since removing the cable shouldn't be required at all unless you've made a mistake on installation. So there you have it, an interesting product which tries to do something about a problem I've been vocal about in the past. But this sort of thing lives or dies by its availability and actual usefulness when out in the wild. Anything that saves me time when up a ladder has got to be good. So we'll see how readily I can get hold of them from the likes of CEF and how practical they are to actually use out in the field. I'm sure it won't be long until the call comes from someone else who wants decorative lights installed in place of their trusty plastic pendants. Cheers.